Hi, this is the second video for Waveform Generator. The first video I showed an overview of the program, and in this one I will go through the basic waveforms. As I showed in the first video, you have these three complexities of waveforms, and in this one we'll only be using the advanced waveform. In this video I will not go through the phase converters or the value converters. I will only concentrate on the waveforms. When you create an advanced waveform, you always begin by choosing a waveform, a basic waveform, as your starting point. When you have not selected anything, none is shown as in this example. And the non-waveform is simply a mathematical function that no matter which phase you input, it will always output 0. So you will have this line here. Choosing a waveform, you simply have this drop down, and here you have a list of all the waveforms. And they are listed as the most basic you find in your synthesizers: a sine, a triangle, a square, and a saw, and so on. Choosing a waveform, you will in many cases have one or two variants. These variants are this combo box. It has a name here. You see it shows the name method, and then you can click and choose one of the other variants. Coming to a sine, the only sine is this one, sinusoid, and the other waveforms I choose to place here because I feel they are in this same family as a sine. So you have this sinusoid, you have an ellipsoid, you have an S-curve with 3 segments. It begins here and ends here, the first segment, the second segment from here to here, and then the third from here to here. And then the last one is simply an S-curve with 3 segments. So you have an extra point here. So these are the 4 different kinds of methods you can choose for sine. Going on to the next, you have a triangle. If you know the math behind these waveforms, you will know that a triangle is made, can be made from multiple harmonies added together. In this case, when it's simple, it's not made from harmonies, it's simple linear interpolation. So you have a straight line and another one here and a third one here. However, you can choose the number of harmonies. And as I choose less and less, you will see the peaks are starting to be more and more rounded. So this is the lowest. If you make a triangle of only 3 harmonies, this is how it looks. And again, as I add more, you'll see it. The 2 tips here will be more and more sharp. Besides choosing the harmonies, you have a second variant, and this is an amplitude factor. To create a triangle from a number of harmonies, those harmonies need to have a specific volume or specific amplitude. And here you can choose that factor. Changing that factor will change how the waveform looks. So you can make it more sharp, or you can make it more round, almost look like a sine. Proceeding to the next, we have a square. Again, when choosing simple, it's simply a linear interpolation where the first 180 degrees will output the value +1, and the last 180 degrees will output the value -1. However, you can choose the number of harmonies here. It says 3 harmonics, but actually it's only 2. It's because when you make a square, it's only made of the odd harmonics. So when it says 3 harmonics here, we are adding the first harmonic and the third harmonic. We are skipping the second. So adding more harmonics, you will start to see this pattern. And like the other one, to produce this one, the amplitudes of those harmonics need to be special fixed values, and here you can change those, and by doing so you can change the appearance of this waveform, so it almost again look like a sine. Going on to the saw, it's the exact same principle as before. When it's simple, it's linear interpolation from +1 to -1, or we can change it to be built from multiple harmonics. And again, we can change the amplitude factor of those harmonics. Going on, we have the Sinc waveform. The Sinc, I have chosen to implement it using 3 different methods. The number factor decides how many of these ripples you see. So as I increase the value, you'll see more of them, and these peaks becomes more narrow. It defaults to 4. And here we have the first method. It's simply we have the phase from here to here, and then the last part it's mirrored and flipped over here. Choosing the second method, you only see that first half we had before, but again you can change the factor. And the third method, you see that peak. It's the same as we saw before, but it has been shifted left. So it will always begin here at 0, and we will see the first peak, and then the factor, we can choose how many of these ripples we will see. The tangent is a bit special. If you know the tangent function, you know that when it reaches either 90 degrees or 270 degrees, the values will go to plus and minus infinity. So in reality, this one would go on forever up, and this one would go forever down. However, I have chosen to interpolate. So we only see the first, in this case, we only see the first 89 degrees of the phase, and then it stops. And here we see the last 89 degrees of the phase. And it simply do a linear interpolation between those two, S-curve interpolation between those two values. And that's to get around the issue with a function going to plus and minus infinity. And as you can see, as you increase this interpolation, you get this this shape that's here. It's more like almost a triangle in the beginning and almost a sine here in the middle. This is method 1, and it have a method 2, and it's simply a copy of it because the real tangent function will actually be looking more like this. So this is method 2 of this waveform algorithm. Going on, you see we have up here we had the square and the triangle and the saw. Here you see the same name with the sub in front of it, and that's because the harmonics have been subtracted. The square waveform is made by adding all the odd harmonics. This subsquare is made by choosing the first harmonic and then subtracting all the following odd harmonics. So it looks nothing like the square, but again, it's made from more or less harmonics, and you have this amplitude factor that can change the appearance of the waveform. The subsaw is the saw is normally adding all the harmonics, but the subsaw is subtracting them. And again, you can choose the number of harmonics, so you get these different waveforms, and you have this amplitude factor that can change its appearance. The sub-triangle, same principle, but a different output. You can add, you can increase or decrease the number of harmonics to have this heart shape. And again, you can change the amplitude factor to make it more like a sine and increase this shape. Then we have a number of random methods. Again, to produce the saw, we are adding all the harmonics. In this case, with the random harmonic, we are adding random number of harmonics, and you can choose the steps, meaning how many harmonics are added, and then you have for each of these different steps, you have 100 seed values, and these seed values are used to seed the randomizer. So changing the seed, you will see we get different waveforms. Here we have 10 steps, 10 harmonics, and here we are randomizing which harmonics we are using. And we can increase the number of steps, and again, we have 100 different seed values to randomize it. I will skip this random rounded for now and go on proceeding the random linear. The random linear is simply choosing random values and then draw straight lines between them. Here it's 3 steps, and it means it's 3 line segments. So we are choosing 2 random numbers, this number and this number, and then we simply draw straight lines between them, and you can see they're evenly spaced. For example, if I change to 4 steps, you can see the first step is with this line, the second step with this line, the fourth with this line. And again, we have 100 seed values. So changing these seed values will randomize how the waveform looks. When you choose the number of steps, you will see every second have this plus and minus. For example, if I choose this one 8 steps, you can see in some cases you'll have multiple points on the same side of this 0 line. So here you see you have actually 4 in a row. You have this point, this point, this point, and this point. They're all below the 0 line. If you choose this one plus and minus, it will alter. Here you have one that's minus, so the next will be plus. This one is minus a little, but still a minus, and then a plus, a minus, and a plus, and a minus. And again, you have these seed values. So as you can see here, when it's with this plus minus, it seems to change less than if it's like this. You get more different waveforms. And the one we skipped before, random rounded, is the exact same as we saw before. However, instead of drawing straight lines, it's drawing S-curves. So we have a point here and a point here, and you see we have an S-curve from here to here, and again from here to here, and so on. So it's the same principle as before, but just with S-curves instead of straight lines. This one, noise, it will produce noise. When you make noise with this program here, you cannot make white noise, because when you export this file, it will be exported with between 128 and 2048 samples, and that is not enough samples to produce white noise. But this noise, I don't think anyone would use this waveform on it in itself, but you can use it to manipulate other waveforms when you make a compound or a partial waveform. And that's why that when you choose this noise, it's called thinable, because when you change its first variant, you can thin out, so you will have fewer of these noise grains. And as with many of the others, you have seed values to seed the randomizer, so you see different results. Let's look at the next. For now, I'll skip these because these don't have combo boxes. They instead have an edit button that will open a form. So I'll skip them for a few seconds and go on to this one called multiplication ramp. This is not a waveform that is intended to be exported as it is, but it's intended to be used as a multiplication. And the ramp is because it ramps up or down. Here you can see it's ramping up. It's the ramp direction, and it's a linear ramp. For example, I can change this to down or up, down or down, up. Here it's still linear, so I can change it to something else, an S-curve, a sinusoid. Sinusoid it is because these are convex shape, and you can change it to a concave shape instead. And here you have them, one concave, one convex, and reverse. Here you have it with ellipsoids. This is the multiplication ramp. We also have this multiplication ramp jitter. It will add this jitter effect with a sine that where the amplitude will the amplitude will increase. It starts low and it gets bigger. And you see here you can draw a line here, so it's linear, and you can change that. Instead of linear, you can choose these sizes you saw before. But as I said, these are not intended to be used as audio waveforms. If I just for a second choose, for example, a sine here in a compound waveform, and I choose the multiplication ramp. Let's choose this one. And I can multiply these two, hence the names. This is why it calls a multiplication. You see, when multiplied, we get a different result. Or we can choose, for example, one of the others. We can choose a saw. We get this weird looking one. So that's those special purpose waveforms. Now let's go back to those that are a bit more advanced. Before that, I see I skipped this one. It's a random S and H is short for sample and hold. It get a random value, then it holds that value, and then it get another random value and holds that. Here we see two steps, and the plus minus like before. If it's plus minus, you'll have one on the plus side of the 0 line here in the middle, then the next minus, then the next plus, then the next minus, or you can go back. Here we have a plus and a plus after, and again a plus and a plus and a plus. And for each of these choosing the steps, you can choose different seed values. Again, you have 100 seed values to choose from. Let's have a look at the basic additive. And as I said before, instead of two combo boxes, we now have an edit button. Choosing edit, we can draw in the harmonics. I have some quick buttons here. For example, as I told you, a square waveform is made of all the odd harmonics. And pressing this button, you see it's very clear here. You have the first harmonic. Over here you see the harmonic and the value of the volume. So the first harmonic, we have 100% or full volume. Here at the third harmonic, we have 1/3 of the volume. Here at the fifth harmonic, we have 1/5 of the volume. And here at the seventh, we have 1/7 of the volume, and so on. So it's all the odd harmonics. Right now, they're shown linear. So you can see the height of this one is 1/3 of this one. But in this case, it would be more easy to see what's going on choosing a logarithmic scale. And then you can see we have a straight line instead. This was the square. Choosing the saw, it will be the same as before, that the first one is 100%, the next is half, the next is third, the next is 1/4, the next is 1/5, and so on. But we have all the harmonics. And the sine is simply the first harmonic. Instead of choosing these four, you should see these 3 buttons as choosing an example. I can simply click and hold the button, and I can move the mouse so I can draw in these harmonics. If I want to, I can right click and I can choose specific values. For example, when you draw a volume, it's difficult to, if I want the first one to be 50%, it will be hard to dial in exactly 50%. So what I can do is I can choose one of these menus. Here I see them in steps of 25%, so it's easy to pick 50%. Here I see them in steps of 10, so I can choose 40, for example. And the rest of the menu, you'll see it in fractions. 1/4, 1/12, 128th. If I press and hold Shift, it will be drawn in red, and it means, as you can see over here, it means it's a negative value. So this one is a negative 69%. And choosing this inward sign, I can change it to a plus and change it back. Instead of hand drawing freehand, as I'm doing here, I can also say I want to draw it in as a line. So when I click here and hold the mouse, I will draw a linear shape of these volumes for these harmonics. While I have my left mouse button pressed, I can click the right mouse, and that will cancel that draw operation. Here we saw linear, so I can choose an S-curve instead. We can draw it as a convex sinusoid, or concave sinusoid. That was by I pressed Control C. You can press Control C and Control Y for undo and redo. Another thing that's worth mentioning is we have this harmonic pattern. Right now it just say plus, and this pattern is repeated as many harmonics as there are. So even though I only entered a single, or it defaults to a single plus, imagine you have 128 of them. And that's why when I draw, all 128 will be added. They will be positive. I can change this pattern. So, for example, if I want to make something that resembles a square, for a square you'll have only every odd harmonic. So I can see +0. And then when I draw, it will only draw every odd. And you have some different, you can pick here, but you can enter yourself. For example, I can say plus minus 0, 0. And you see when I draw, the first will be blue, meaning it's added. The next will be red, meaning it's subtracted. Then the next two will be skipped because I have 0, 0. And since this pattern is only 4 characters long, it will repeat those 4 characters over and over. And I can combine it with different draw operations, so I can draw an S-curve with this pattern. Right now it says begin at first harmonic. So, you know, the plus should be blue. However, if I start here at the second harmonic, it will be red. And that's because we say begin at first harmonic. If I unclick that, now when I click this one, this will be the blue one, the next will be red, and the next two will be 0, 0. Instead of drawing a pattern, you also have this one generate from pattern. Pressing this button, it will open a new form. We can choose a harmonic count. For example, we not greater than 128, but I can say I want 64. And I want those 64, for example, if I want to generate, here we have a saw. It's because it says plus, it's all of the harmonics. If I say plus 0, I will add each second harmonic, hence it will be a square. And I can choose the amplitude of these. This one indicate the amplitude of those 64 harmonics. Right now, it's default to 1 divided by a harm. It will be the harmonic. So the first harmonic will, the volume of the first harmonic will be 1 divided by 1, and that will be full. The next will be 1 divided by 2, and so on. So we see this pattern. Right now, when it's this one, you see these controls are locked. I can also say full volume. You see it's here, it's full. I can still not change it, but I can also go to a linear. So now, instead of auto scale, I can flip the values. You see here now a line this way. If I flip them, it's the other way. Or I can choose the volume of the first and volume of the last, and I can choose if it should be a linear or an S-curve or these different shapes. And when I have something that I'm happy with, I just press OK, and these values are transferred into this part. Up here we saw all the volumes, but instead of drawing volumes, you can also draw the phase. It means where the waveform should begin. If we go to a sine, right now the phase is 0. You see it says 0 degrees here. However, if you change this one, you start to shift the waveform, and it can produce different results. For example, it can be a bit difficult to get an exact value here. It jumps in 5. As you can see here, it jumps in 5 degree steps. But like before, you can right click and say I want it to be 180 degrees exactly. And we can draw in the others, and we can change the faces of those. So this is how the basic additive works. Basically, you just draw in the volume of the harmonics, and then you draw in the phase values of those harmonics. You can also ask it to randomize. So you can hit randomize until you get a waveform you like, and then you can change what you dislike. If I change it back to freehand. What I do is I simply click somewhere, drag the mouse down, and when I still have the mouse button selected, when I move right, I simply clear those harmonics. So that's the randomize. I can also load a waveform from the database and then resample into a basic additive. So this one, you see it has sharp corners, but actually it preserved this one really good, but often you will see a bit of a change when you resample a waveform into a basic additive. This one I know I cannot resample into a basic additive. We can try, but it will be something different. So here you see it gets this ripple effect when you have a sharp corner. So that's how you resample something into a basic additive. The next one we will look at is the advanced additive. And as the name implies, it's more advanced than the other one. So instead of simply drawing in the harmonic values, we have combo boxes for these. I can choose to add them manual and say I want to add that a wave line, I call these. I can choose if it should be active or not. I can set the full harmonic. I can set a fraction of the harmonic. I can set the volume. The way it works is you add some lines. Then when this line is selected, I change the value for that one line. Or if I choose all of them, here I've selected them all. And instead of saying I'm adding sines, I can see I'm adding saws, or I'm adding squares, or I'm adding triangles, ellipsoids, tangents, Sinc functions. But instead of manually adding these lines, what I can do is I can say I want to make a saw. And I can say make it with 7 harmonics. And when I press set, I will have 7 lines here. And they produce this saw. Or for example, if I say square, I will have this one. You can see it's the first harmonic with full volume, the third harmonic with a third of the volume, the fifth harmonic with a fifth of the volume, and so on. What I can do now is, for example, I can skip the first and select these 6. And then I can say I want to randomize these I have selected. Right now, only active is selected. So when I randomize, it will randomize which of these will be active. And that will produce different shapes. I can also say, instead of, if I set them all active, I can say I want to randomize the waveform they're made from. So I get these different shapes. Or I can randomize the operation instead of adding them all. Some will be subtracted, some will be multiplied, and perhaps some will be mixed. If I hit, again, here we have a mix. So that's a way to produce different waveforms. Instead of starting out with these, I can go back and say I want to draw it. I want to start out by doing, for example, I want to begin from here. And now it will set these wave lines to values that match that one I got from hand drawing. So I have a starting point. I can use the form we saw before. But this time when you call it from here, you can actually go higher than, you can go to 512 wave lines. So I get this result instead. Also, I have this randomize. Many forms you'll find this randomize, and many times I will use it to find something I like, and then I will change what I dislike. For example, this one looks interesting. If I want to hear it, I can simply double click, and now you can hear how it sounds. I can randomize again a few times. Double click. Randomize. When you hear it here, you can turn the volume up and down, or you can move this one to change the octave. It's worth pointing out that this playback feature is very simple. It's not meant to be very sophisticated. It's just to give you an idea how the raw waveform sounds. And how the raw waveform sounds is actually not the interesting part. The interesting part is what you can do with it when you bring it into your synthesizer. Here I have selected to show it with sample-it, and it's just to give me an idea if I were to write this out, which samples will actually be included in the file. It has nothing to do how it sounds, and this is not choosing how to export it. It's simply a visual effects to give an idea. For example, here with 600 samples, which point that will actually be in the file. You will not have this button. It's something I have for this debug version. So these are the advanced additive, and as you saw, that you can do a few more detailed things like choosing different waveforms, choosing different operations. You can set the phase in 1 degree increments instead of 5 degree increments. So it's a lot more nerdy to use, but it's more advanced. You can do more things, and as I said, this randomize feature can give some interesting waveforms that you can change features, or once you have it generated, you can say, okay, I want to randomize some of these values. And when you have something you like, press OK. If you press randomize one time too many, you can just Control-C to go back. So these are the advanced waveforms. Again, you can load from the database. Doing so, it will be resampled. It will be resampled up to 256 harmonics, but if you don't like or need that, for example, I only want have up to 100, I can select these lines and see delete, and it will be changed. So that's the advanced. Next one, we have the hand-drawn waveforms, and it will not be a surprise. It lets you hand draw. When I move the mouse, you see I have a blue cursor across that lags behind my real black mouse cursor. And that's because I have asked it to snap to these intervals. The default interval you will have, each of these squares will be split into 6 by 6, into a 6 by 6 matrix. So you see, when I move up, it steps here first, second, third, fourth, fifth, sixth. And I can choose different steps. For example, if I choose max resolution, you see the blue cursor, when I move the mouse quickly, it will lag behind, but as soon as I place it somewhere, the blue cursor will be placed exactly where my mouse cursor is. And you have these snap points. When you start drawing, it will snap to your these red points that are selection points. These red points indicate where a draw operation is starting and where it's ending. Here with nothing, we have a line. It's starting here and it's ending here. You have different tools. For example, if I want to quickly draw a sine, I can choose this sinusoid. Down here it says use shift for altered effect, and when you hover the mouse over, it will show what it means for each draw operation. For example, here without shift, I draw this one. I let go of the left mouse. When I start drawing here, I get this shape, but when I click and hold shift, I get this shape. So while still holding shift, I let go of the mouse. Then I draw the next segment without shift. And the third one, when I press shift and let go of the mouse, I have a perfect sine, and now you see these red dots show exactly each of these different segments where they start and begin. The actual waveform is shown in blue, and while I draw, this orange one will indicate what will change. So if I let go of the mouse, this is how it looks. I press Ctrl C. When you do a draw operation, if you want to cancel while still holding the left mouse button, I simply click the right one time, and that will cancel the draw operation. If I choose freehand, I can draw freehand, but if I press and hold shift, it will jump to those snap points that I have set up here. Here it's 15 degrees. If I choose this one, 5 degrees, and I draw with shift, you see the steps are smaller. I undo a couple of times. If I do the line, I can draw a line, but if I hold shift, it will be a straight line, horizontal line. And I press the right to undo. I can also draw an S-curve. And if I press shift, it will be a sharper S-curve. We already saw the sinusoid, where the shift flips between a convex concave. And the same with ellipsoid. For example, if I want to make the middle, shift, and without shift. When I have something drawn like here, I can add noise. So if I click here, you see I will add noise. This noise, you have a beginning amplitude and an end amplitude. When lock is selected, it will be the same. So if I change this one, for example, to 1.10, it will change down here. If I unlock it, I can see I want to start with a low value and I want to increase it to 1.20. So as I start drawing, for example, this first half will have less noise and the noise grains will increase in amplitude. I undo. I can also set the width of these noise grains. For example, I can set the width to 5 degrees. So now when I add noise, you see the noise grains are wider. And if I press flip, you see these two values, they will change. So here I was increasing noise, and now the last part I am decreasing noise. And here if I press shift, the noise grain will be changed into this rounded shape. So let me undo a few times and undo those also. One thing worth mentioning is you can only draw left to right. If I click the mouse here and move right, it's okay. If I click the mouse here and move left, it's not possible. You have this, it will clear the last part here. Over here, it will not go to the left. So only draw from left to right. we can randomize the drawing, and what it will do is it will, here we have 4 draw sections. When I randomize it, it will add a random number of draw sections, and each draw section will be different using these different tools. So you can get some interesting waveforms. In many cases, I will choose randomize, and then I will hand through the things I want to change. For example, I might want to do an S-curve from here down to here, and then back up here, and you see it will, when I get near, because these snaps are active, it will snap to that red point. And again, I can press shift to have this altered effect, and for the S-curve it's a sharper S-curve. When I have a drawing like this, I can choose to smooth it. And when you smooth it, you have this smooth factor, and it tells how closely it will smooth according to my drawing. And if I want to include this point, you see now it's excluded. In order to get it included, I need to change this value. But instead of you having to undo the draw operation, change this value, try to smooth again, while you still hold the left mouse button, you can use the scroll wheel to change that value. So I can change the value till I get the smoothing effect I want, and I can let go of the mouse. I undo. If I press shift instead, then instead of these smooth lines, it will reduce it to straight lines. So it will reduce the number of samples in use, and then simply draw straight lines between those samples. So here I use the smoothing effect instead. I can also load a waveform. This one is made like a compound waveform. So what I'm doing here is I'm actually resampling into a hand-drawn, and once it's hand-drawn, I can click OK, and then I can add all kind of phase and value converters to it, or I can say it's okay like this, but I want to add noise to this part of the waveform, or whatever I want. I can also import a wave file from disk. Here I have a wave file, and when I import it, it will simply resample that waveform. So that's what you can do with the hand-drawn waveforms. Normally, to hear how a waveform sounds, you double-click this screen, and it will open the playback window. However, if I start to double-click here, it thinks I'm drawing. So I undo that. So that's why you have these play buttons in this form also. Otherwise, I can simply press OK, and then when I return to this one, I can double click and see this window. Next on the lists, we have the Numeric Sample-and-Hold. As you saw up here, we have this random sample and hold, where you can choose a number of steps, and you can use a randomizer to randomize these values. When you choose this numeric sample and hold, you have an entry field where you can see you can enter the digits 1 through 9, where 1 have the value of 1, 2 have the value of 75, 3, 4, 5, you have a value of 0, 6, 7, and so on. And if you want to make one of the steps wider, you simply repeat that value. For example, this one we have, that's 5. We can simply add more 5 to make that step wider. So it's an easy way to let you build a numeric sample and hold waveform instead of using the randomizer, or instead of hand drawing it. You can simply make it by entering these numbers. Instead of entering these numbers manual, you can also use the randomizer. Here I have set a length of 10, and right now it says 1 and 9, and you can see 1 is +1 and 9 is -1, so it will add 10 steps that will randomize either be 1 or 9. I can choose 1, 5 and 9, and 5 is here in the middle. Or I can choose different subsets. Here, all of them. And for example, we can say we want 20 steps instead. So that window you saw before where we had 100 different seed values, here you can randomize all that you want. And if you choose this randomize all, it will randomly pick one of these, and it will randomly pick a different length. So it's totally random, and you'll get many different. It's simply an easy way to generate a sample and hold waveform. And the last one is simply made from mathematical expressions. You can enter an expression. I have some sample buttons here. Here we have sine of x. And as you can see, x holds the phase in radians. So it begins over here with the value 0, and it increases all the up to here to the value of 2 times pi. And taking the sine of that, it will produce this waveform. This button called saw. You see here we have the first harmonic, the second harmonic, the third, the fifth, fourth, the fifth, the sixth, the seventh. This one called square. Here you have the odds, the first, the third, the fifth, the seventh, the ninth. Here we have sine of x as we had in this one, but we add a random number. R is a random number. Here I divide R by 20 to decrease the amplitude of the noise I'm adding. If I just add R, it will look like that, and I can say R times 4. You almost cannot see the sign anymore, but by reducing this number, we can choose a higher or lower amplitude of that noise we are adding. R is a random number that changes for each and every phase value. So none of these values are the same we are adding. But we have other, for example, we have these R0 to R9. If I press this expression help, I get this help window. And here you can see R0 is a random number that's held for 1 degree. R1 is one that's held for 2 degrees. R2 is held for 5 degrees. So if I instead say R2, you see we have these steps that we are adding. And to make those steps wider, we simply choose one of the other random tables. So for every step, it'll be wider and wider. And last, we have this one with pi. It's used in some of the formulas. For example, here we have pi. This example shows how you can use an if. If x is less than half of pi, we output sine of x. So that's this part of the waveform is generated here. And if x is not less than pi divided by 2, we see this part of the waveform that generate the rest. So this is how you can use if. It's actually an if then else. If this then else. This one, we have two nested ifs. When you do two nested ifs, like we have here, we have a if here and we have if here, you need to pay attention to these parentheses. If we forget one of them, we get this one error in expression, and it cannot generate the output. So doing these ifs, you need to pay attention. These ifs are also written here. It tells how you should read that if sentence, what it means. Here we have some other mathematical functions: sine, square root, power. Here we have pi minus x. As you know, x starts as 0 and goes to 2 pi. So pi minus x will generate this saw table, this saw waveform. And the reason it will do that is because no matter how the values will be output from this formula, from this expression, it will normalize the waveform in its outputs down here. And that's why, for example, if you choose this one, sine of x, if I multiply it by 2, it will not change anything because it's normalized. Likewise, divide by 2, it's still normalized. This one, square plus minus, it's the same odd harmonics like for the square. However, this time I also between subtracting and plussing. So subtract, plus, subtract, plus, subtract, plus, and you get this output. P is a special variable also. The first 180 degree P will output the value +1, and the last 180 degree it will output -1. So here we will, the first part we are adding 1 to our sine, the last part we are subtracting. And we can, of course, make that smaller or larger to change the effect of it. And here we have simply the mathematical function to produce a sinc. And in this case, the sinc is shifted. Normally the sinc will, this peak will begin up here. But here I have shifted it, so it will be in the middle instead. And you have a randomize function. It's very simple, but you can use it to get a starting point. But otherwise, if you know a mathematical function, you can enter it here. So this is the expression waveform. And now we have looked at all the waveforms, and as you saw, you can generate thousands of waveforms by using either the different variants as it has here, or you can use the more advanced one of those that has a method that lets you hand draw or do additive waveforms or whatever. So these were all of the basic waveforms. In the next video we'll look at the phase converters.